last session on section 12.6, and if it's too loud and is hurt, if my mic is too loud, is it okay? Not hurting your ears? Okay. So last time we talked about 12.6, and that was the polar, cylindrical, and spherical. Polar is a review. Cylindrical, we decided that we're just dropping down a perpendicular from any point to xy plane. And then from there, the basically intersection of that perpendicular to xy plane acts like a polar. So this one is just a polar coordinate. X and y are the polar coordinates. And then, so this was the last time, and we were here. So the formulas are going to be x equal to r cosine theta, y equal to r sine theta, and z equal to z. Now, we were over here. We converted a cylindrical point, r, theta, and z, to Cartesian. Now we're doing the backward. X and y and z are given to me. Now I want to convert to r, theta, and z. We decided that z is going to stay the same, right? So z is going to be 1 still. I found r. That's good. I also found tangent of theta. How did I find tangent of theta? It's y over x, right? Which is 2 square root of 3 over negative 2, negative square root of 3. So negative square root of 3 is associated with negative pi third, right? If I do the arc, I get negative pi third. Here's a little problem. What is the problem here? According to x being that and y being that, which quadrant am I in? I'm in the second quadrant. And so this is not a second quadrant, so I add a pi to be in a second quadrant. 2 pi third. Sorry, it got messy a little bit. Now, therefore, the point r, theta, and z is going to be 4, 2 pi third, and 1. Fair game? Okay. Let's go to the next one. Questions? We're good? So I'm moving on to the second. Now here. It's asking you to describe this surface. Can you tell this is a cylindrical coordinate surface? Yeah? It has r and z. What do you guys think c is? C is a constant. Right? Now, I'm supposed to convert this to what's the other one? Cartesian. So I'm going to convert to Cartesian because a lot of times it's easier for you to convert to Cartesian. I'll talk about something else as well. So z in Cartesian is z. What is r in Cartesian? R squared in Cartesian. X squared plus y squared plus c squared, right? This looks sort of familiar. I did this a little bit, but I'm not 100% sure. So let's go to power 2. I'm going to power 2. So here I'm just replacing r squared by that. Converted. Now I went to power 2. Can you guys tell me what shape this is? Is it a cone? If C is not 0, is this a cone? No, it's not a cone. So what's the other one? Hyperboloid. Is it 1 sheet, 2 sheets? It should be, hold on. If I plug in Z is not like the others, right? Z doesn't have the same sign. If I plug in Z equal to 0, what do I get? X squared plus y squared equal to negative C squared. Is it possible? So there is a gap. There exists a gap, correct? So it's hyperboloid of 2 sheets. Now that I know, wait a minute, but hyperboloid of 2 sheets, what does it look like? It's in the Z direction, by the way. Looks like that, right? But this is a function. Vertical line test can be both of them. It has to be just one of them. Which one is it? The top one, because Z is positive, right? Because that associates with plus and minus. So not this, but this, check mark. So that's one way to convert. But the other way to think about, and you're going to do this in the lab. In the lab, I'm going to ask you to graph this equation without conversion in R and Z. When you graph this equation in R and Z, you end up with a shape that looks like this. That's R, right? It looks like this. Wait, I have an R and Z looking like this. What is R and Z? R and Z is any theta constant going around. So from here in the lab, you figure out that if I spin this around, I also get that shape, if that makes sense. Right? So in R and Z, if I graph it and think about R and Z is just theta any constant, and I can spin it around. When I'm spinning it around, it's one thing that you did in CAC 2. What is that called? You did volume of rotation. This is going to be just the object of the rotation. I'll leave this for the lab next week. Okay. Now let's go to the second picture. Now I'm asking you, in cylindrical, we're asking you to describe this solid region shown below. What is the, so in this course we go back and forth between surfaces and solids. Can anybody tell me what's the difference between surface and solid? What's the difference between surface and solid? So Alyssa, if I have a cylinder here, right? Do you think this cylinder, this empty cylinder, is it a surface or a solid? That's a surface. If I have this filled up, do I have a solid or a surface? I have a solid. So that's the difference. Inside of it is entirely filled up, basically. Now, in here I'm saying this solid, right? Can you guys tell me, inside this solid, how is Z value changing? What's the smallest Z? What's the biggest Z? Now tell me, what about R? What's the smallest? What's the biggest? 2. So if I was just going to describe this as that shell, as a surface, R would be 2, not between 0 and 2. It's because it's a solid, you have to imagine that all these points inside have smaller R than 2. Make sense? So all the points inside, look at the shell. Can everybody see this from the back? That's my cylinder. Points inside are going to be equal or less than 2. It's going to be less than 2. And R is bigger than 0, so that's the limits that I'm getting. Can anybody tell me how theta is changing? 0 to 2 pi. Fair game? Okay. So for this solid, what do you think? Oh, they both go from 0 to 3. What happens to R? Again, 0 to 2. Now, big question is, how does theta change? Hold on. Do you see this? This is the y-axis. This is the x-axis. If I'm looking at xy plane, what quadrants this shape is above that quadrants? 1 and what else? Oh, it's not on 2. 2 would be x negative. It's y negative, x positive. 4. So now can you tell me, so if this is the xy plane, now can you guys tell me what limits is appropriate here? What is this? What is that? Let me show you in GeoGebra. So in GeoGebra, that's the shape. Do you guys agree this is the shape? Okay. Now, I'm looking from above, so I'm putting Z into my nose. And you can see that the shape is above first quadrant and the fourth quadrant. Okay. Do you guys need 10 seconds to talk to each other about this? Do it, because I'm asking a question from you now. And the other points actually are points inside. Questions for me? Yes. Louder. Oh, it's a negative. My negative mixed into pi. Yeah? Everybody okay on this side? We're good? Can I start again? Let's start at eye clicker. I get select. Come on. Eye clicker time. Switch. What is going on? Everything is okay? You don't have any questions? Are you good? Oh, you can talk to each other about this. No, it's not a test. It's something for you guys to give you a minute to think about stuff, right? The eye clickers are not tests. You're Natalia. Okay, I forgot your name. For this one or for that one? Oh, for this one? For the eye clicker? No. For eye clicker, you just need to use your conversion formulas. So you have x, y, and z. R is going to be what? Square root of x squared plus y squared. Theta is going to be, tangent of theta is going to be y over x. Right? Chloe, you're okay?
Because your point is in the first quadrant, which means it can't be y.
Jacob, no.
And since
Marcus.
we've already kind of figured out that R
Marcus.
is 3 root 2, that has to leave C. And this is 3 root 2.
I don't know their names.
Yes, 3 root 2
Oh, this is overwhelming. I'm going to learn your name. Bix. Oh, William, I know.
Eric.
June, I know. Oh, no, I'm getting overwhelmed. Eli, I know. I should know. You're big. Okay. Oh, we're getting there. So what is R? So what is that? What is theta? Tan of theta is equal to 1. What quadrant is theta in? Quadrant 1. So that angle. Is everybody okay? And z, does z change in cylindrical? No. 4, 3. Is this a game day? Yeah, I assume that as much. 2, 1. No, I know it's a game day. I'm being sarcastic about it. 0. Correct. That's the 3 square root of 2. This is theta equal to 5/4. Let's start the next section. So I want to talk to you about spherical now. Spherical coordinates. What is up with spherical coordinates? Let me draw a picture. Let's see if you guys can follow. If not, use the page over here. Fair game? So I have a point, my friends, I have a point in 3D. I'm planning to connect that point to origin, connect to origin, find the distance of the point to origin. That's, I'm going to call it rho. Rho distance to origin. Then I'm going to drop down an orthogonal. Orthogonal drop down to xy plane. When I drop down the orthogonal to the xy plane, I'm going to connect it to here also. But before that, I forgot to do one item. Let's go do it. I'm going to drop down another orthogonal to z axis. That's an orthogonal. It just looks differently, right, from when you do 2-dimension. Now, this orthogonal, I am going to call the angle. This is the point P. The angle between z-axis and OP is going to be, is called P. OP like vector, z-axis like a vector. So that angle, I'm going to call it P. Here's my z-axis. Raise your left arm. Left arm raised. Choose a point in the space, and then your fist to be that point. Fist in there. Now, your shoulder is going to be angle phi. This straight up, this is fist. Shoulder is the origin. I'm sorry, shoulder, your shoulder is origin. The angle that your two arms are making is going to be phi. So if I'm in the above xy plane, is phi, what is the range for phi above xy plane? 0 to pi over